Why are these bridge piers made into an arc shape instead of being straight? So is this a genius design or a graduate's mistake? Today, let's dive into this question. A viaduct like this is composed of piers, a cap beam, bearings, and box girders. If conditions allow the piers to be built like this, that's obviously the best. But if the piers have to be placed in the middle of the road, affecting traffic, then they must be moved inwards into the greenbelt. Doing this creates large cantilevers at both ends of the cap beam. Here's the key part. At each bearing position on the cap beam, there is a concentrated force. The bending moment of the cantilever beam equals the sum of the force multiplied by the distance, and its bending moment diagram looks like this. Under these forces, the cap beam will also deflect. The limit for this deflection is 1/300th of the cantilever's length. If the cantilever is too long, the calculated reinforcement might be too much or uneconomical, or the deflection might exceed the limit. In this situation, there are generally three solutions. The first is to shorten the longitudinal distance between the piers. This reduces the force, so the bending moment and deflection can also be reduced. But for the same length of the project, the number of piers will increase significantly, making it extremely uneconomical. The second solution is to increase the height of the cap beam's cross-section, but doing this raises the road elevation, which might be restricted, and it also increases the amount of concrete used. This is not an economical solution either. The third solution is the best. If we move the pier slightly outwards, reducing the cantilever length by 14.3%, the bending moment of the cap beam can be reduced by 25%. The deflection can be reduced by about 30%, which might pass the calculation. It's also very economical, as the reinforcement is also reduced by 25%. But by doing this, the piers are back on the road again. What a headache. At this point, structural engineers came up with a fourth solution: make the piers curved. This way, it both reduces the bending moment and deflection of the cap beam and doesn't affect traffic, making it extremely economical. But a smart person like you will surely say, how can a curved one be as good as a straight one? You're right. As early as 2010, research was done on this. If we only look at the column, under gravity load, the curved shape will indeed create an eccentric bending moment. At the same time, it will have a tendency to expand outwards. But looking at the entire structure, because of the cap beam, this middle section will provide an axial tensile force to the columns. If we design this middle section of the cap beam as an eccentrically loaded tension member, it can provide enough of a tying effect to the curved columns to maintain the overall stability of the structure. The theory might be a bit complex, but what I want to say is, to build a wide bridge deck in a limited space, this shape is often the optimal solution.